In this video, we'll look at optimal pricing under third degree price discrimination. So first of all, what is third degree price discrimination? So that's where the monopolist is selling output to different people at different prices, but every unit of output sold to a given person sells for the same price. So what that means for each person is, no matter how much they buy, they're going to be paying the same price per unit. But different people may be paying a different price per unit. So we saw some examples at Real Cinema Hull. In the box here, you can write down your own examples, but there's also a link here where you can contribute examples for the rest of the class, or you can see what examples others have contributed. So if you click that link, you'll be taken to a page where you can write down examples of third degree price discrimination. So that's the definition of third degree price discrimination. So now let's look at optimal third degree price discrimination, and we're going to see how the optimal prices depend on the elasticity of demand in each of the markets. So first of all, let's remind ourselves of what the elasticity of demand is and how we can write the marginal revenue of a monopolist in terms of the price and the elasticity of demand. So here I have a formula. So this shows the marginal revenue is equal to the price times 1 minus 1 over the elasticity of demand. So let's remind ourselves now what the elasticity of demand is. So the elasticity of demand is equal to the negative of the derivative of the quantity demanded with respect to the price times the price over the quantity. So note here, because I've put the negative in front of this derivative, this thing is going to be positive. Some books do it a different way. They don't add the negative here, so the elasticity of demand would generally be negative. But the way I have defined it, it's always positive, as long as demand is downward sloping. Okay, so this is the slope of the demand function. So what does this mean? Well, let's think about this and think about what derivatives are. This is approximately equal to the negative of the change in Q over Q. That's dQ over Q is approximately the change in Q over Q. And then we're dividing that by the change in P over P. That's the dP over P there. And then what is that? Well, that's just a percentage change over a percentage change. So this is the percentage change in Q, the quantity demanded. It's a change in Q over the value of Q. So it's the percentage change in Q. And then we again have a percentage change, the percentage change in P. So the elasticity is a percentage change in quantity demanded over the percentage change in the price. So as an example, if the percentage change in the price is 1, then the elasticity is equal to just the negative of the percentage change in the quantity demanded. So it tells us how much does the quantity demanded change in percentage terms when the price goes up by 1%. So if the elasticity were 2, then a 1% rise in the price would cause a 2% fall in the quantity demanded. So that's the elasticity of demand, specifically the price elasticity of demand. So this marginal revenue formula shows how the marginal revenue depends on the price and that elasticity. So the bigger the elasticity here, the smaller is this term, and the closer is this to the price. So with the bigger elasticity, the marginal revenue is closer to the price. With a smaller elasticity, the price is further from the marginal revenue. So we're going to use that marginal revenue formula to see how the optimal prices depend on the price elasticity of demand. So let's think about an example where there are two submarkets. So there's a submarket called L think of it as the low demand market, like the students in the cinema example. And then we have a high demand market, so think of this as other adults in the cinema example. Now we know that profit maximization requires that the marginal revenue is equal to the marginal cost. And we're going to assume here that the marginal cost is a constant equal to C. So that means that in each market, so in market L and market H, the marginal revenue has to be equal to the marginal cost at the optimal quantities. So the optimal quantity here in market L I've denoted with a QLD, and the optimal quantity in market H I've denoted with a QHD. So the D here stands for discrimination. So if we look at those two equations, we see this marginal revenue is equal to C, this marginal revenue is equal to C, and so they must be equal to each other, right? So at the optimum, the marginal revenue in each market must be equal. Another way to think about this is if the marginal revenue were different in each market, then the revenue could be increased because we could reallocate the quantity sold from one market to the other. So from the market with the low marginal revenue to the market with the higher marginal revenue. So now let's look at how we can apply the marginal revenue formula. So we take that elasticity formula for marginal revenue and we just plug it in down here. So for the marginal revenue in market L, we just take this formula, but now we have the P, the price in market L, and the quantity in market L, and the elasticity in market L. And then we do the same thing for market H. So these are now the price in market H, the optimal price in market H, the quantity in market H, and the elasticity in market H. So we have this formula saying the marginal revenues are both equal. Now let's see what that implies about the optimal price and how it relates to the elasticity of demand. So when specifically is the price in market L, the low demand market, going to be less than the price in market H? So let's suppose the price in market L is less than the price in market H. When is that going to be true? Well, if this number here is less than that number, then this number must be more than that number. Otherwise, these two things would not be equal. So it must be that this inequality holds. The thing in the bracket here is bigger than the thing in the bracket here because this is smaller than that. Now let's rearrange this inequality. So first of all, let's just subtract the ones from each side and get rid of these negative signs. So if we multiply both sides by -1, then that's going to reverse the inequality sign. So we'll end up with 1 over the elasticity in market L must be less than 1 over the elasticity in market H. Or if we solve, so if we multiply through by epsilon H, the elasticity in market H, we'll end up with that on the left-hand side. And if we multiply both sides by the elasticity in market L, and the inequality is like that. So we found that at the optimum, the price in market L is less than the price in market H, if and only if the elasticity in market L is more than the elasticity in market H. So what this says is that the price is going to be lower if the elasticity is higher. So that is if the demand is more price sensitive. So a lower price is charged where demand is more price sensitive. A higher price will be charged where demand is less price sensitive. Let's think back to the example of the cinema. Students are charged a lower price than other adults because they're more price sensitive. And so why might students be more price sensitive? Well, if we think about their incomes, usually they're lower, and so a cinema ticket would generally be a higher proportion of their income, and so they're going to be more affected when the price of a cinema ticket goes up. They'll reduce their demand by more.